Lesson 1, Natural Selection. So before I give you all the scientific details about what natural selection is, let's examine a population of colorful ants. You can see here we have ants that are white with blue eyes, blue ants with red eyes, white ants, red eyes, white ants, blue eyes, red ants, blue eyes. What we have here is what we would call variation. There is a variety of forms of this specific trait in this population of unknown bugs. But unfortunately for this population, it turns out that this bird here really likes to eat the red ones. So what this means is it gives the other forms, the other variations, a reproductive advantage. It's advantageous to be a blue bug or a white bug, but it is not an advantage to be the tasty red bug. When this variation is heritable, meaning it can be passed from one generation to the next, we see that we end up with a population that has none of the tasty red bugs and a majority blue and white bugs. This changes the population over time, and what we call this is natural selection. So here at the top is our natural selection recipe. We have 3 ingredients, we whip them all together, and we get something we call natural selection. So let's examine the first ingredient, variation. Variation is that difference amongst individuals in the population. Natural selection cannot occur if variation does not exist. For example, if we look at this population of giraffes, we have variation in the lengths of their necks. Variation can be very small, but if that variation leads to an advantage and is heritable, natural selection can occur. With the giraffes, this individual variation gives some an advantage, where they may be able to eat those leaves that are just a little bit higher up. So when everybody else eats the ones that are low, the individual who can eat them just a little bit higher has a reproductive advantage with its variation. Variations can come from a couple places. They come from mutations. So mutations are completely random. Mutations arise randomly. If it happens that that random mutation is an advantage, that will lead to natural selection. We can also get this through meiosis, through independent assortment, where the chromosomes from mom and dad randomly line up to end up in each gamete, and through sexual reproduction, where individual organisms are recombining their genes together. So rather than just cloning yourself, which gives you no variation, we have 2 completely different organisms, individuals, that are recombining. With this variation, there must be some difference in the ability for the variants to survive and reproduce. If there is no advantage to being a blue bug or a white bug, then we will not see a change in the population. In this case, the advantage was the birds don't eat you as often, so you're going to survive to reproduce. We describe this as the word fitness, which is just a measure of how many offspring an individual has. More fit offspring, or more fit individuals, have more offspring. The last ingredient is heritability. This trait must be genetic, meaning it has to be passed from one generation to the next. If it's not a heritable trait, natural selection cannot occur. At the same time that Darwin was trying to form his theory of evolution as we know it today, Jean-Baptiste Lamarck also had a theory, and he thought that the parents could acquire traits and pass those to their offspring. So if we go back to our giraffes, he thought that if giraffes stretched their necks really far to reach the leaves on the tall branches, that their necks would get longer, and they could pass that on to their offspring, who also would have longer necks. We know this isn't true now. It has to be heritable, and it has to be something found in our genes. So natural selection sounds like a great process that makes really well-fit organisms for their ecosystem. But mutation is random, and this means that sometimes the mutations that pop up are positive, meaning they give them an advantage, and it gives them something new to have competition with other individuals. But sometimes those variations are negative. We've looked at lots of disorders that are negative to an individual in a population, and then sometimes these variations do nothing at all. They're completely neutral. It's helpful to remember that natural selection has absolutely no goals and cannot create perfect organisms. It has no thought process behind it. It's just a mechanism that drives the process of evolution. And it can only work with what's there. Fitness can change over time. If at one point your variation was the ideal form, but your situation changes. For example, if we look at the woolly mammoth, once the ice age was over, it was no longer an advantage to be a giant, hairy, elephant-like creature who had specially adapted blood cells for cold weather, because there was no longer extreme cold weather, and they did not adapt as well as a population to the warming climate. So remember, natural selection is not something acting on an individual. It's at a whole population level. Individuals cannot adapt themselves. So organisms can't control or will themselves to evolve. If we could, I would have 4 arms. It would be so much more useful. These genes for the variation have to exist or arise in the population in order for them to be selected. I cannot be a mermaid because those genes do not exist. So to summarize, natural selection is just a mechanism for evolution. We don't control that in a natural population. Mutation is random. Nothing is perfect in evolution, and organisms cannot control their evolution because the genes for evolution and natural selection to act on have to arise. You can't will them into existence.